Next rule to look at is our product rule. There's the formal definition of the product rule, but again, it's not how I remember it. Much easier to remember like this. Write down the first, diff the second, plus write down the second, diff the first. Again, you do it as you say it, and it becomes a very natural thing. Now, reality, yes, you'd probably expand that one out first. I mean, it's quite easy to do. But let's use the product rule for it. Write down the first. Well, the first thing I've got there is x to the power of 7. Differentiate the second. Well, the second thing I've got there is x to the power of 9 minus 6. If I differentiate that, I get 9x to the power of 8. Plus, write down the second. Okay, x to the 9 minus 6, diff the first. Differentiate x to the power of 7, I get 7x to the power of 6. This probably now explains why I probably wouldn't use a product rule for something like this, because I'm going to have to do an expansion anyway in the next line. So I may as well have done the expansion in the first line. Right, so expand it out, collect like terms, and we have our derivative. Again, similar sort of thing, binomial product, not hard to expand out, but we could. Write down the first, x minus 2. Diff the second, differentiate 2x minus 3, we get 2. Write down the second, 2x minus 3, differentiate the first, 1. Bit of expansion, collecting of terms, we have our answer. Now, just because it's written in a different form doesn't change the rule. It's still a product of two functions, hence why it's called the product rule. We have a product of two functions. Write down the first, x to the 7 minus x3, diff the second, 6x. Plus, write down the second, 3x squared plus 7, and diff the first, 7x to the 6 minus 3x squared. Expand it out, collect like terms, our answer is there. Because now, this is where the product rule becomes useful. Because to expand this one all out, yeah, it's going to take a bit of time, bit of a pain. Write down the first, 3x. Diff the second, but now the second one we use the chain rule for. Bring down the power, 5. Lower the power, 4. Diff the inside, well, differentiate x squared plus 4, we get 2x. Plus, write down the second, x squared plus 4 to the power of 5. Diff the first, 3. Ooh, tidy all that up. The advantage now is, because I didn't expand out at the top, I'm not going to expand out now, because we have like terms. Whenever we factorise, it's the lowest power we factorise out. So x squared plus 4 to the power of 4, they both have, leaving me with 30x squared plus 3 lots of x squared plus 4. We get the common factor out. 2x times the square root of 2x minus 1, well, I've got to put the 2x minus 1 into index form. Now, we can use our product rule. Write down the first, 2x. Diff the second. Again, I'm going to have to use the chain rule. Bring down the power, a half. Lower the power, minus a half. Diff the inside, differentiate 2x minus 1, we get 2. Plus, write down the second, and diff the first. Tidying that up. Again, we have common factors. And just because one's a negative power doesn't change our rule of factorising. We still pull out the lowest power. So the common factor there, yes, there's the 2, but also the 2x minus 1 to the minus a half, leaving me with x plus 2x minus 1 to the power of 1. There's the mere mortal answer. There we go. Super mathematician answer. Put it in third form. So there's our product rule that we can use for calculus.